Inventory management plays a critical role in business operations. It involves the tracking, controlling, and optimizing of inventory to ensure products are available when needed while minimizing excess stock. Efficient inventory control reduces costs, improves cash flow, and ensures a smooth supply chain. Inventory includes materials and goods held for future production or sales. It's both an asset, ensures continuity, and a liability, ties up capital. For example, an automotive supplier may hold raw materials, work in progress, and finished goods. The main inventory types are raw materials, VIP, finished goods, and MRO supplies. Effective inventory management ensures smooth operations and cost control. The objectives of inventory management are to ensure material availability, minimize carrying and obsolescence costs, and balance customer service with inventory investment. It also supports smooth production flow and schedule stability. A great example is Dell Technologies, which shifted from large finished goods inventories to a build-to-order model, reducing overall inventory days by 60%. Inventory is classified into different types based on its purpose. Cycle stock covers regular demand between replenishments like daily production items. Safety stock protects against uncertainty, serving as a buffer for demand spikes. Pipeline stock refers to goods in transit or in process, like shipments overseas. Anticipation stock is held for seasonal demand, such as winter apparel, while decoupling inventory isolates work centers, like VIP, between processes. Inventory costs include carrying costs, storage, insurance, obsolescence, and capital, ordering costs, setup or procurement, stockout costs, lost sales, idle time, penalties, and purchase costs, material cost per unit. For example, by tracking true cost to hold metrics like rent, power, and obsolescence. Nestle India improved its working capital turnover from 4.1 to 5.0 times per year, demonstrating how effective cost management can enhance financial performance. ABC Analysis categorizes inventory based on annual consumption value, which is calculated by multiplying unit cost by annual usage. Category A items. Approximately 20% of items account for approximately 80% of the inventory value and require very tight control. Category B items. Approximately 30% contribute approximately 15% of value, needing moderate control. Category C items. Approximately 50% make up approximately 5% of the value and require simple controls. For example, in a warehouse with 1,000 SKUs, 200 high-value items may account for 80% of the inventory value. ABC XYZ Analysis helps manage inventory by classifying items based on value and demand patterns. ABC categorizes by value: A equals high, B equals medium, C equals low, while XYZ classifies by demand variability. X equals stable demand, Y equals seasonal, and Z equals erratic. In Siemens Healthcare, WEX items are automatically reordered, while CZ items are manually reviewed or discontinued. This approach reduced excess stock by 18% and focused efforts on high-value items. The Economic Order Quantity (EOQ) model helps determine the optimal order size to minimize inventory costs. The formula is EOQ equals square root to DS, H, where D is the annual demand, S is the ordering cost, and H is the holding cost. For example, with 12,000 units demand, 200 ordering cost, and 10 holding cost, the EOQ is 693 units. This balance minimizes both ordering and holding costs. The reorder point ROP is the inventory level at which a new order should be placed to avoid stockouts. It is calculated as ROP equals lead time demand plus safety stock. For example, if weekly demand is 100 units, lead time is 2 weeks, and safety stock is 50 units, the ROP would be ROP equals 102 plus 50 equals 150 units. This means the order should be placed when inventory reaches to 150 units to ensure no stockouts occur during the lead time. Continuous queue orders are placed when stock reaches or falls below the reorder point ROP. This is used for high-value, critical items. Periodic P inventory is reviewed at fixed intervals and orders are placed based on the stock level at that time. This is suited for low-value, stable items. Example, Maruti Suzuki optimized order cycles by integrating EOQ and ROP in their SAP MM module, reducing stockouts by 20%. This system helps manage inventory more efficiently and ensures timely replenishment. Safety stock is used to protect against the variability in demand or lead time. If safety stock is too low, it can lead to stockouts and delays in fulfilling orders. On the other hand, if it's too high, it results in excess inventory, wasting capital. The formula for calculating safety stock using the statistical approaches, safety stock equals Z times sigma times square root LT, where Z is the service level factor. For example, 1.64 for a 95% service level, sigma is the standard deviation of demand, and LT is the lead time. Safety stock ensures that you maintain an adequate inventory to meet customer demand even when there are unexpected fluctuations, balancing the risks of stockouts with the costs of holding excess stock. A higher service level means fewer stockouts but more inventory. The Z-value determines the stockout risk. For 95% service, the Z-value is 1.64, meaning a 5% stockout risk. For example, with a service level of 95%, a demand standard deviation sigma of 50 units, and a lead time LT of 2 weeks, the safety stock is approximately 116 units. This ensures fewer stockouts but requires holding more inventory. Optimizing service versus cost involves balancing inventory levels with customer service targets. Coca-Cola applied different service targets for each item class A greater than C and used real-time data to adjust safety stocks dynamically. By integrating AI-based demand sensing, Coca-Cola recalculated safety stock daily per region, which helped reduce inventory by 10% while improving product availability. This approach allows businesses to balance service levels with inventory costs more efficiently. Accuracy in inventory is crucial for efficient operations. Inaccurate inventory can lead to shortages, surpluses, and incorrect material requirements planning MRP outputs. For items, a target of is greater than or equal to 95% accuracy is recommended to minimize these issues. Poor accuracy can result in lost customer trust, expedited shipping costs, and increased operational inefficiencies. Maintaining high inventory accuracy ensures smooth supply chain management and cost savings. Cycle counting techniques ensure inventory accuracy through regular checks. In the ABC-based method, items are counted monthly, B items quarterly, and C items annually. The random sampling method involves daily random checks of SKUs, while the process-oriented approach audits inventory after major transactions like receipts or issues. For example, a warehouse with 3,000 SKUs can count 20 items daily, achieving full coverage in 150 days with minimal disruption, helping maintain accurate inventory without affecting operations. Inventory reconciliation and addressing root causes of inaccuracies are key for maintaining high accuracy. Common errors include incorrect data entry, unreported scrap, wrong units of measurement UOM, or theft. Root cause correction is part of a continuous improvement process. For example, Amazon uses RFID-based cycle counting and root cause analytics to pinpoint issues and correct them. This approach helps Amazon achieve over 99.5% inventory accuracy, ensuring better stock control and fewer errors.